and we were doing some descriptive analysis on this particular data set. We were actually provided with the data documentation, and as well I had structured some questions that will help us to doing our analysis. So I hope you guys still have that documentation. I don't know if I can get it from here because my desktop is very rough. But this is the documentation of the data, as well as the structured questions that we are supposed to follow as a guide in doing our analysis. Now from there, you can see the first thing was to code our data set as it was provided in the table, where the categorical variable needs to be defined and all that. So we did the first part, that is A. We are done with A. We also have, we were able to do the descriptive analysis. So we did this descriptive analysis, and now we have to go to inferential analysis. Now from the inferential analysis, we are told that you need to define at least 5 claims, meaning you'll have 5 claims to test. So you need to define at least 5 claims, those are hypotheses, and test these hypotheses by appropriate statistical tests and techniques. So you are required to include some of these tests that are mentioned here, such as the 1 and the 2 sample t-test, because we did this, as well as the paired sample t-test. Quite interesting. Again, we have to find an association, maybe using chi-square test and regression analysis. So where am I getting these claims? How am I formulating these claims? Actually, you realize when we were doing the descriptive analysis, there were some suggestions that we were creating from the descriptive analysis, and more so when we were exploring the numerical variable by categories. I remember very well that at one point we were suggesting, we were even saying, when we were trying to examine the economic status actually, and there's this variable known as CS, which is okay, from the documentation, let's just check, is the credit score before and after COVID-19. And the credit score is the number that represents the likelihood of you paying your bills. So I was saying, when we're exploring the credit score, that is the ability to pay bills with respect to the economic status, at one point, using the box plot actually, at one point we were saying that it could suggest that credit score on low economic status, there is a low credit score on low economic status. So such insights, we need to see such insights. We need to conclude about such suggestions. Is it true that the credit score is being affected by economic status? See, those are the things that you need to ask yourself. Again, at one point we were looking at the hospital anxiety and depression. This is a numerical variable, and we were exploring this numerical variable with a categorical variable here, which is health condition. That is, if one is healthy, if one is you can see there is healthy, chronic, and disabled. And when we were doing that, we also had some outliers at one point, I remember that, and we were even saying that wealth background suggests, okay, this is now back on wealth background. But I was saying on health, there was something to do with health. They were saying those maybe are disabled, have a that is what we were saying. Those who are disabled, of the category disabled, they actually had, they were associated with high anxiety and depression. We cannot, at this point, we cannot say they are associated, but it was suggesting an association. From what we were saying, it was a suggestion that there could be an association between the two. So those are some of the claims you are trying to test and get some insights. And we are actually formulating this right from the descriptive analysis. There are some suggestions and some insights that we can get from the descriptive analysis. Then now we can go ahead and actually test them in the inferential analysis. I don't know if you are getting that. So it is very important as you do your descriptive analysis, more so when you're exploring more variables, maybe two numerical variables or two numerical variables and categorical variables. Try to see what is being suggested at the various categories, and that could formulate a very nice claim. So we want now to do the inferential analysis, and actually we want to do the inferential analysis as required here by first coming up with a claim. After coming up with a claim, of course the claim will be one big statement or a paragraph or just one statement. After having that claim, we formulate the hypothesis. After formulating that hypothesis, actually these are the steps of doing inferential analysis. You first formulate the claim. After formulating the claim, you state the null and the alternative hypothesis. After formulating the null and the alternative hypothesis, you now determine and do the test statistics. If the test statistics has some assumptions, you also check the assumptions. And of course, now later you make a decision rule and a conclusion. So that is what we want to do now. That is what we to do now. Now, because at one point we were, now I'll give this as a first example and we'll do the test. But now as we proceed, I'm expecting you guys to also try to formulate your, your claims based on this data set and based on our descriptive analysis that we did yesterday. And me, from my observation, because I was observing, I was seeing some suggestion on the wealth background and the credit score of the students after COVID-19, their ability to pay bills, and the wealth background was suggesting that if they are not from wealth background, then their ability to pay is quite low. There was just that suggestion. So could there be any association or any effect between the two? You see, that is a claim. So you see that is a claim, and now I can go ahead and test that claim. So for this case, my claim will be, wealth background family has a significant effect on the credit score of students. That is one perfect claim. Wealth background, the wealth background, that is now a categorical variable. Wealth background, coded as yes or no. Seems like okay, something is not adding up, but it's okay. Okay, wealth background, let me just check my data. Wealth background here. Okay, yes and no, but it's okay. So 2 is supposed to be, no, it's okay with your data. There's no need of me doing that. No. And I click OK. So we coded our data yesterday. So okay, it's still okay now that I've confirmed it's coded. So I was saying that one perfect claim is that the wealth background could affect the ability of students to pay their fees after COVID-19. Now the claim is wealth background family has a significant effect on the credit score of students. Now you see that is a claim. The claim now needs to be tested. So to test this claim, we first have to formulate a hypothesis. So we are coming up with the following hypothesis. And I hope you guys are following. Wealth background family has a significant effect on the credit score of students. That is now my claim. Now my hypothesis, for the null hypothesis, I'll have wealth background family has no significant effect on the credit score of students. See, in terms of statement, the null will have the word no. So wealth background family has no significant effect on the credit score of students. Now my alternative hypothesis will be the wealth background family has a significant effect on the credit score of the students. I think this is what we were basically trying to do the other time. This is basically like what we were trying to do the other time. Now I have formulated my hypothesis. I have come up with the claim, I have formulated the hypothesis. Now I need to go and determine the test statistics. Now, someone maybe to give a trial, what could be the appropriate test statistic for this case? We have wealth background here, credit score here, measured as a numerical variable, and we have wealth background here, which is measured as categorical variable with 2 levels. That is, yes, I'm from wealth background, and no, I'm not from a wealth background. So what could be the test statistics? What do you think could be the test statistics here? But this is very simple because it is what we have been doing actually. We actually talked about this the last class. Look at the credit score. The credit score is a quantitative variable, this one. We can all see that it is a quantitative, it is numerical and continuous in nature, this variable. Now look at wealth background. The wealth background here is a categorical variable, or rather qualitative variable, with 2 non-overlapping categories, yes or no. And these 2 categories are independent, like you being from a wealthy background does not in any case affect the other person who is not from a wealthy background. So they are non-overlapping. So they are independent. So because this credit score is continuous and numerical, and wealth background is categorical with 2 categories which are non-overlapping, in other words, which are independent. Isn't this the independent t-test we were talking about last time? And the data was just like this, only the names are changing. Because I remember the other time we had a mathematics score, or statistics score, and then we have sex or gender, male and female. Actually 2 categories, just like this data. So it's independent sample t-test to test that claim. Why? Because 1, we have a numerical variable and is measured in terms of a categorical variable that has 2 levels that are non-overlapping. So we will go with the independent sample t-test. Remember, we said there are the assumptions that you need to check, and one of them is the normality assumption. So you need to check if the data is normal distributed. You need to check if the data is normal distributed. Otherwise, you don't have even to bother about reading the output if the assumption do not hold. So we are going with independent sample t-test for test for normality, we can do what we call the Shapiro-Wilk test. That will also be okay to check the normality assumption. And now for independent sample, I know you guys know how to run the procedure. So to do the independent sample t-test, we basically go to Analyst. Because of time, I will not check on the normality of the dependent variable, but you can do Shapiro-Wilk test. It's just a simple test. So we go with compare, means actually I did checking the normality, it's normal distributed. So we'll go for independent sample. Now here we need to move the tested variable. We are moving the continuous variable, that is the credit score after COVID-19. And now for the categorical variable, we are moving, what did we say? Is it wealth? Yeah, wealth background. We are moving wealth background here. Now the question mark is because we have not defined our categories. So we have 1 and 2. That is from wealth and not from wealth. 1 and 2. We of course click continue and we click OK. And we have our output. Now one thing I need to confirm is on the wealth background, because when interpreting, so 1 represents yes from wealth and 2 no. So now we have our output. Do we have our output really? Why do we have the statistics alone? Okay, let me just check. Are you guys getting the output from your end? Okay, independent sample t-test 1 and 2. Okay, options 95, everything is okay. And I click OK. The independent sample table is not produced. Why is it not produced? There is a warning here. And it is this. Are you guys getting the independent sample?
From my
At least one of the group is empty. Did I not define my groups? Okay, let me just check that one more time. But I have my two. Oh, now I know the reason. I know the reason. You see, there is a problem with my dataset. This one. Oh, the 0 here. Why am I having a 0? This is the problem. The data is coded differently. Was it supposed to be 1 and 0 or 1 and 2? Let me just check. Wealth background, it's yes 1 and no 0. Okay, that is the problem. So I'll come here and say yes 1 and no is 0. And no is 0. So I'll click add. So remove that and I click OK. So now when I go and run the independent sample t-test, I'm expecting now to have it. But now we need to change the other group to 0 and say continue and OK. And yeah, we are there. So it was a problem with the data set, like defining. That is important to always have the documentation and all that. So that is our output. Can someone now do the conclusion? I'll just say that our claim was the wealth background family has a significant effect on the credit score of students. And the null hypothesis was wealth background family has no significant effect on the credit score of students. And the alternative hypothesis is wealthy background family has a significant effect on credit score of the student. We have determined the test statistics to be the independent sample t-test. Now we have the output. Can now someone tell us from this output? Because this is what we were doing the other time. So just someone to say something. Kindly. Let's make this session. Come.
Yes, I have a question, Prof.
Yes, Walter, you are saying something. Lawrence.
Yes, I think I have a different output.
Yes.
You can see like the 5% confidence. Like my upper, it's 37.746. I can see yours upper is -2.6. For any my outcome, they are different from yours. They're vice versa.
No,
the lower is upper and my upper is lower.
My upper is also 37.746 here.
No, that's your lower. Lower.
Oh, lower.
Yes. So mine is upper. Upper is 37.
You're saying yours is... Oh, yeah. It's okay.
It's okay.
It's very okay.
Oh, sour.
Okay, now this is what is happening. Yeah? You have defined your groups differently from mine.
Yes.
I started with 1 and then 0.
Oh.
And you could have started with 0 and 1. Did you do that?
Yes, I started with 0. Yeah.
Now, what is happening here is, in this case, here you have no, yes. And I have yes, no here on the statistics.
Oh, yeah.
Are you seeing that?
Yeah, I can see that. Yes, I'm seeing it.
So, when computing the difference in mean, mine will be the first mean here minus the second mean. That is the mean for yes minus the mean for no. And you can see the mean for yes is less and for no is bigger. So then the final answer, the difference in mean, will be negative. Now this difference in mean is used now to compute the t. Now because the t is, the difference in mean is negative, the t now will also be negative. Now because the t will be negative, it is also used to compute the confidence level, that is the confidence interval of the difference, which again will also be negative. So what is changing for me and you, or what is different, is the sign, that is the magnitude or the size of the values is the same. Are we communicating, Walter?
Yes, we are. So should I proceed with this one, or I need to change?
In this case, if mine was positive, then you realize 37 should go to the lower and 37 should go to the upper and 2.6 be on the lower.
Yes.
Now that doesn't make any difference, because you realize at the end of the day we will have the very same conclusion, and that is the most important thing. So if from my output here, if I reject the null hypothesis or I fail to reject, definitely you'll do the same, because we have the very same t-test only that the sign is different. But look at the significance value. They're the very same, I'm sure.
Yes, yes, the significant value are the same.
Yeah, so we have the same output. Now I want someone to try to interpret. Someone to interpret. We did this last class. Yes, Morrison.
I didn't get the question well.
Okay, the question is to interpret. Like we have the output. Now I want someone to try to do the interpretation like we did last class.
Okay.
Yes, that's the assignment. I mean to be done right now. It was very clear. I remember that time. Okay, the video is there. Okay, I'll post the video tomorrow. The t-test, the independent sample t-test will always give us these two tables. Of course, we'll get the normality test on a separate table. You need to run the Shapiro-Wilk test on its own. Now, we have the group statistics and we have the independent sample tests. So from this group statistics, I was saying the other time that this is just like when we split the data file and then we run a descriptive and a descriptive statistic. There is a descriptive procedure and a descriptive statistics. It will give us a summary statistic based on the groups you have used to split your data file. So this is what we have been having all along and we've been doing the interpretation. So I'm not going to focus on this. I'll just focus on this independent sample t-test. Now we said the other day that before you even start your looking at the t-tests and all that, first you need to check, that is the equality of variance, because it is this Levin test for equality of variance that determines which row of the independent sample t-test we are going to use in interpretation, or rather in making our conclusion, or rather in testing our hypothesis. Because you can see there are two here and all of them have some value. So which one do we use? That all depends with the Levin test. So the first one is when the equality variance is assumed. We use now this first row. And the second row is when the equality variance is not assumed. So first we need to deal with the Levin test. Now I remember very well the other day I was saying for the Levin test, that is, we are testing for the equality of variance. So if the significant value, if the significant value is less than the confidence level, that is in our case the 5% confidence level, then the assumption does not hold. But if it is greater than 5% in this case, then the assumption holds. The equality of variance assumption is not violated. So from this case, the significance of the Levin test for equality of variance is greater than 5%, our alpha value. So we therefore conclude that the equality of variance assumption is not violated. So for that case, we will use the first row in our testing. We'll use the first row of the independent sample t-test. This row you are seeing my cursor moving. So that is it. That is the first thing. You need to determine which row you'll be using. Just to give you some knowledge as to why I'm saying that when the significance value here is less than alpha, that is 5% in our case, then the assumption is violated or that does not hold, is because of one thing. And this knowledge we have, it is based on the hypothesis. You see, I'm trying not to bring all those hypotheses for this case, just to have it for the T maybe. But the fact is that here we are still also testing a hypothesis. Remember, we are testing for equality of variance assumed. So the null hypothesis will be, yes, this is now it, the term I was looking for. There is no difference in variance for the two groups. So the variance are equal in simple terms. And now the alternative will be, there is a significant difference in the variance. So when the p-value is greater than 5%, we fail to reject the null hypothesis, which states there is no significant difference in variance, which means it is equal. So for this case, I normally, because we are not interested in, making a conclusion, we are only interested in knowing if the assumption holds or not. I normally avoid that statement of forming the hypothesis. I just say the null is the variance are equal, the alternative, the variance are not equal. So if we fail to reject, it means they are equal, and now it is holding. So for this case, it holds. For this case, it holds. Now again, the other time I was saying there are three methods now to deal with the conclusion of the t-test. You can use the t-test itself, but you need to compare it to the one obtained from a table under these degrees of freedom, and of course the 5% two-tailed. I'll not bother about that, but it is easy to use this significant value and maybe the confidence difference here. But let's just dwell on one. It's normally good to dwell on one, so I'll dwell on the significant value. And we can all see that the significant value of the t-test is 0.24, which again is less than 5% significant level. So, because it is less than, we of course reject the null hypothesis, which the null hypothesis states that wealth background has no significant impact on the credit score. And if we reject that, then what will we conclude? We will conclude that actually wealth background has a significant effect on the credit score. So that is it. So you first have to determine the Levin test, and then now proceed to the t-test and make your conclusion. And the same, I can use the confidence level here. We said that last time, if the confidence level contains 0, then we fail to reject the null hypothesis. If it contains 0, we fail to reject the null hypothesis. So if it does not have 0, we reject. Now you can see it is starting from -37 on the lower to -2. You see now we need to go to -1 and then 0. So the confidence interval does not contain a 0. So we therefore reject the null hypothesis. So either you use the 95%, you use the significant, or you use the t, you'll have the same conclusion. But in most of the cases, we will always be dwelling on the significant of the test, the significance of the test. That is what we'll deal with. So generally, I was suppose you are writing this. Now remember, you only need like a paragraph for this. You don't have a page for this. Nobody will do all that reading. So try as much as possible to make it short. Like I would say, from the t-test output, the equality of variance assumption is not violated, since the p-value of the Levin test is less than 5% significant level. And I'm done with that Lavin test. I've just stated that. From the output of the t-test, the equality of variance assumption is not violated since the p-value of the Lavin test is greater than 5% significant level. The significant value of the t-statistics is 0.024, which is less than 5%, and we therefore reject the null hypothesis and conclude that wealth background family has a significant impact on the credit score of students. And you are done. You don't have to include do a lot of wording and all that. That is more than enough for this case. That is more than enough. So, any question? Anyone with a question? Yes, Saif.
Okay, Prof, I hope you can hear me.
Yes, loud and clear.
Okay, procedurally, in performing this test, after realizing that we were to use the independent sample t-test, we first hypothesized, then formed a null and alternative hypothesis. Then I would like you to clear some doubts on the output now. No, something isn't clear on my side. After getting the output, where we have the group statistics and the independent sample t-test table, and you said to start off, you first start with the Lavin's test for equality of variance, whereby we check the significance value of the Lavin's test. And if the value is greater than 5%, we say equal variance assumed is not violated, and vice versa. But now, Prof, from there, after deciding whether to use the upper row or the lower row, kindly clear on that. And I was reading an article somewhere, some times back, and somebody was just interpreting based on the significance value of the Lavin's test and not coming up with these other stories. How about that? Thank you.
Sorry for that. And thank you for this awesome question. Actually, Seth reminds me of it's always bad to mention your competitors, but it just came in my mind. When I was doing my undergraduate, so to speak, I was really into data science then. So any chance I had to enroll a course and do it. So at times back, I joined one of these online courses, and I was actually enrolled for the very same packages that we're doing today. That is the quantitative package. So those they were doing two. They were offering two actually. So they were doing eViews and the SPSS. Yeah, eViews and SPSS. So I'll not mention the name because I'll not mention the name. But what happened is that at one point we were doing t-test. So you see the problem with at that time is that it's not that I didn't know the softwares. Actually I did, but I wanted to see if there's anything new that I learn and all that. You see, learning is a continuous process. So in the process, the instructor did an independent sample t-test, one like us here, one like just we have done here. And then what was happening is that we were actually concluding and making, we were just reading the t-value and making a conclusion without even bothering of the Levin test and all that. So we were looking at the t-value. If the significance is less than, we are failing to reject. And if it is greater than, of course, the vice versa. So one student had this question, but from that table, I see there are two t-tests. So when do we use this upper one and when do we use this one at the bottom? And this instructor was like, you see, these values are just repeated. They are there. So you can actually use any. And in most of the cases, you will find that they do not have a big difference as such. So you can just use any. And I was like, no, what about those assumptions and all that? So later on I was interrogating, okay, of course you don't. So later on I was interrogating this instructor and he was like, you see, in that class we are trying to avoid these statistical issues and all that. But you know you are a statistician. So you are bringing a lot of aspects, which are, okay, you can bring that on your own, but don't mention such in such a class. But even if it's the statistics, but the statistics is setting the rules that are to be followed, why should we keep it aside? Anyway, that was just by the way, so that I thought it was wise to give the ice break on my own, because you guys didn't want to. Now, this is another scenario Seifo is talking about, that he's saying that he was reading an article, I don't know, and they were making a conclusion already using the Levin test without even bothering about this. Now that is a new story in town. I've never actually seen that. And I like the way he was putting it, because he was saying procedural. And at one point I thought he wanted to mention something that I didn't do, but I deliberately skipped that step. After we have tested the hypothesis, stated the claim, the hypothesis and all that. Actually, the first thing before doing a test is to check the assumptions. That is the first thing. Now, the other time we were mentioning 3 assumptions, and one of them, which is also very important, is the normality assumption. Then we have the Levin test. Now you see, because the Levin test will always come with the independent sample t-test, we first always have to do the normality test, which I said I'm not going to do, you guys will do. And in this case, we use what we call the Shapiro-Wilk test. It's very simple. Now this, at least you guys should learn something on your own. Go and Google and say how to do Shapiro-Wilk test for normality. They'll go to analyze here and you are done, or go to data there and you are done. So that is the first thing. Then after now doing that, we will come now to run the t-test itself. And it will give us this descriptive analysis as well as this one here for the independent sample t-test. Now, this is what is supposed to be, like this is the procedure of interpreting, and it will always be the procedure. And I'm telling you, you can go anywhere you go and you'll find it this way. We first check on the Levin test. We first check on this Levin test. And after checking the Levin test, one, we were saying, we look if the equal variance assumption holds or not. Now the reason as to why we are checking for this assumption, if it holds or not, is to decide which row are we going to use in doing our interpretation. Are we going to use the first one or the second one? So if the equality of variance assumed holds, like the assumption is not violated, then we are using, remember this column here is the equal variance assumed is not only for this Levin test here, but it is going through the entire table. this row. So this output for t-test is in the case when the equal or variance is assumed and its degrees of freedom, its significant, its difference in mean, and all that. Now, when this assumption is violated, here, we then use the second, because actually the second is the opposite of the first. That is equal or variance not assumed. Now, this is the t-value when the equal or variance is not assumed, like the assumption is violated. Its degrees of freedom, its significant value, its mean difference, and everything. So we check first the equality of variance. And the reason as to why we are checking that is to determine if this assumption holds or not. If it does, we use the first one, this one, the equal or variance assumed. If not, we use the second one, equal or variance not assumed. And let me tell you a secret now that will never make you forget if the assumption is holding or not. You see this one, the first one, equal variance assumed. When I'm testing Levin test, this one is my null hypothesis. This one is my alternative hypothesis. I'm giving you now a way of mastering this. Equal or variance assumed is my null hypothesis. Equal or variance not assumed is my alternative hypothesis. So from the t-test, from this significant value of the f-test, because the Levin test uses the f-test, the significant value is greater than 5%. So we fail to reject the null hypothesis, equal or variance assumed. And we fail to reject it means it is true that the equal or variance is assumed. So the assumption holds, it is not violated, and I use the first row. If it is violated, that is, the significance value here is now less than 5%, meaning we are rejecting this null hypothesis. So we are failing to reject this, that is, we are accepting this, that equal or variance not assumed. We are using this second row. So it is wrong and very wrong to conclude on the independent sample t-test using the Levin test. Like you are now testing using the Levin without bothering. But it's independent sample t-test. I don't know if I've answered your question, Mr. Saif. Okay, I can see Saif is saying very well. Any other question? Any point that is not clear? Any concern? So, yes, Mr. Morrison.
I have a small concern.
Yes, please.
This the interpretation part.
Yes.
I think if you could be sharing some form of handouts, because sometimes grabbing everything at once will be a problem to some of us.
Okay, Mr. Morrison, I'm getting your concern. Now, what I'll do?
Yes, maybe a short summary.
Okay. That is okay, Mr. Morrison.
Okay.
Because you guys in this class have been very nice, though at times you don't want to interact. I'll give a report on this project we are doing together. Like, I'll write everything and share with you tomorrow once we are done. And actually, today is Wednesday. This is the last class we are having on SPSS. Because tomorrow I'll be having R all through the week. So next week we'll be starting Stata. I'll give a report on this that will act as your guide in your interpretation. 1. 2, I'll also give a reference material for SPSS, very procedural and all the interpretation. So your concern is, I mean, everything will be okay. I'll take care about that. So if there's no any other concern, let's finish our 30 minutes looking at another case. So we have formulated our first claim for this particular data set. We now need to form another one and maybe do the analysis. So someone to think about something. What do you think could be the other claim? Now, at one point we were mentioning about health. There's something about health. Okay, we have this one here, health condition, and also have blood group. Now you see the two. What if this particular, health condition could be having an association with the blood group? I don't know if we have a medic in the house, but it could be like those in group AB, maybe they are healthy more than those in O and all that. So there could be an association as well or something. And actually this is one perfect example because all the variables are categorical. So we need to ask ourselves, which is the test statistics? So we might be interested to investigate the health condition and blood group if they have any kind of association or other relationship. So I can formulate a claim and say there could be a relationship between blood group and health condition of students. Now you see that is not a claim using the word could. Or is it a claim? I think for it to be a claim, I then say there is a relationship between blood group and health condition of students. Or there is an association between blood group and health condition of students. Now I need to test that claim. Now the first thing before I test the claim is to do, to state the null and the alternative hypothesis. And for the null hypothesis, I can say there is no relationship between blood group and health condition of students. And of course, for the alternative, I can say there is a relationship now between blood group and health condition of students. So you see, those are the claims. You just formulate them. Now, the test statistics. What could be the appropriate test statistics? Someone to tell us what could be the appropriate test statistics. You see, they are both categorical, but we talked about this one time. What could be the appropriate test statistics?
What if I say chi-square?
Sorry, who is that speaking? Duncan?
Yeah?
Okay, you are the one saying chi-square.
Yeah.
Why do you think chi-square?
Because both are categorical.
Awesome. That is perfect. That is very perfect. So Mr. Duncan is telling us that we can actually do chi-square since both variable are categorical. And that is it. So it's chi-square, guys. It's chi-square. So you see, when we're doing that report, actually you need to tell why you're doing that test statistics and all that. That is why I was asking Mr. Duncan, why do you say chi-square? So I can say, since the variable blood group and health condition are categorical variables, then the test statistics is chi-square test. And we did chi-square in this class. If not with the SPSS, then we did it with the Excel. So to run a chi-square, we did it with SPSS, I remember. Go to Analyze, Descriptive Statistics, and Cross Tables. Now from there, you can now formulate your tables the way you want them to be. So we have blood group and health condition. So it is just a table, so one in row, in column. So okay, let me just check the variable. It is not wealth condition, but health condition here on the rows, and then I have blood. Was it blood group? Okay, blood group here. I move with that. So you can check on extract, but that is not important. Most important is the statistics. Now under statistics, you can see there is chi-square and there is correlation. So we want the chi-square. I remember saying this, that correlation analysis is used to measure the association, or rather to assess the association between continuous variable, whereas chi-square is now used to test the association for categorical variable. See, that is it now. That is it. Now, so we are selecting chi-square and I click continue. So that will give me the table. Just forget about the rest, the cells and all that. We are not going to do. We're just interested to get the chi-square test for the case of inferential analysis. So these are the case summary. These are like a descriptive summary. You can see the health. Those who are health and blood group A, they are here. So this is what we call a cross table, or rather cross tabulation. At times you may be told to find or rather generate a cross table. That is how we also do about that. But now at the end of the day, if we have checked for chi-square, we will have our chi-square table like that. So someone to interpret the chi-square, because we did that. Who is interpreting? Who is doing the interpretation? But this is very simple. Now, I know we were confused because we have several rows. Now we look at the Pearson chi-square. These are just various procedures of computing the chi-square, but we are dwelling with Pearson chi-square. So this is the chi-square value. Just like the t, we are having a t value. Now here we have the chi-square value. You can use the chi-square table and compare and make a conclusion at these given degrees of freedom. But we have its significant value at two-tailed. So we can just use the significant value. So the interpretation is more or less the same. What you need to know is your null and alternative hypothesis. If it's less than 5%, or rather your alpha value, we reject the null hypothesis. And if it's greater than your alpha, that is 5% in this case, we fail to reject. And now you make your conclusion. That is the decision rule. So in this case, I'll say the significant value of the Pearson chi-square test is 0.440, which is greater than 0.05. Now it's greater. So what do? We therefore fail to reject the null hypothesis and conclude that there is no relationship between blood group and health condition of the students. You see, when we say we fail to reject, is like now you're accepting it. That is why now we are concluding on the very same. I don't know if that is clear. I don't know if that is clear. So if you understand that, kindly type 1 on the chat, and if not, kindly type 0. Oh yes, I see we are all of 1. Now, that was awesome. We can also make another claim. So who is making a claim now from the data set that we can now test? Because now what is remaining is making some claims, testing, but we need to take note of the conclusions, so that at the end of the day we are able to come up with one general conclusion. So maybe we do 2 more claims before we conclude. So any other claim that you can think of from the data set? Most importantly, look at this. You see, we want to see if COVID-19 affected the students. Now, we have their credit score before and after. Can't you see that these two are measured at 2 different time instances? They are actually the same. I mean, same variable, but now was measured at 2 different time instances. The other day we were doing paired t-test, and I was telling you it's either the observations are pairwise or they are measured at 2 different time instances. Like we are having, and that time we were using an example of math score before and after. I mean term 1 and term 2, and we are comparing. Why can't we do that for this? That is after and before. Their credit score before and after, to see if there is any significant difference in their average credit score, in their average ability to pay for their bills. We can do that for before and after. So I'm not going to do that because that is very simple. That is paired t-test, and it's what we did last time. So sorry for that. Any other thing, claim that you can think of? But we were looking at wealth background and their ability to pay for their bills. We did that, background and the ability to pay their bills. What about economic status? I think economic status also affect more. Okay, that's a claim. It could be affecting their ability to pay. So you see, there are actually several claims that you can make. And for me, I'll basically concentrate on the credit score because it's what is affecting the life of comrades the most. These are university students. So their credit score, ability to pay bills, and economic status. But now something amazing and surprising is that the credit score has 3 levels. We have low, economic status is categorical with 3 levels. We have low, medium, and high. So if someone wanted to say we can do an independent sample t-test because this one is continuous and this one is categorical with 3 levels, I would ask them. But when we were doing their SPSS was only giving us a room for 2 groups here when we're defining groups. So where are we going to define the third and all that? Now, I remember the other day I was telling you that actually the independent sample t-test, whatever you do with the independent sample test, whatever it qualifies to do the independent sample t-test, at times we use what we call the one-way factor ANOVA. That is, we are doing an ANOVA test. Now in this context, it's more applicable because we have actually more than 3 categories. We have actually more than 2 categories, that is. So we can actually formulate a claim and do this ANOVA. I think this is one way we can learn ANOVA. And it's not anything different from what we're getting from regression. The ANOVA table. So I'll formulate a claim and say economic status has an impact on credit score of students. You see, that is a claim. We are not sure if economic status has actually an impact on credit score of students. So to test the claim, we can formulate the following hypothesis. We can say for the null hypothesis, it will be economic status has no impact on credit score of students. And now the alternative will be economic status has impact on credit score of students. So now, since the variable credit score is numerical, that is continuous in nature, and now the economic status is categorical with 3 non-overlapping categories, like you being of low economic status, there is no way you will affect the one in the medium in normal circumstances. Like kama mimi sina pesa, I'll not affect you not having money. That is maybe what I'm trying to say. So they are non-overlapping groups. So the test statistics in this case is what we call the one-way ANOVA. Now, just like the t-test, the one-way ANOVA, or rather the ANOVA test, also has assumptions. And one of them is what we call, or the assumption is the normality assumption. So there is your assignment. Go and check how to do normality assumption in SPSS. It's very simple. And the name of the test is Shapiro-Wilk test. It's very, very simple. Because it's just a matter of navigating and moving the variable. I know someone is saying, if it's very simple, why are you not doing it? Yes, I'm not. You discover some other things on your own. And the second assignment is, the second assumption for ANOVA test is also the homogeneity of variance, just like now in independent sample t-test. Now in independent sample t-test, the equality of variance was coming with the table of t-test. It was coming with the table with the t. What was the last thing that I was saying? Yes, I was saying that I hope that was the last thing you guys we were still together. So saying the other assumption for the one-way ANOVA is also the equality of variance. So you need also to check for the equality of variance assumed. Now I was saying, unlike in SPSS, not SPSS, but in t-test, in doing t-test, we are getting this Levin test for equality of variance alongside the independent sample t-test table. But now in the case of ANOVA, we are not getting that. So you need to do that separately. So again, your assignment is to ask yourself, how can you do Levin tests separately, like just navigating and doing the Levin test. I'm not going to do that, but it is here on these menus. So I want also to discover something and all that. So after checking now for test for normality, which we did in, okay, we didn't do that actually, but the data is normal distributed. Then we do now the Levin test. Levin test assumption, and now after doing that assumption, we now do our ANOVA test. So to run ANOVA, because this is the new thing, you just go to Analyze. You just go to Analyze. Or you guys want us to do the test as well? Which one do you prefer? Are we doing the test as well? So we move now our dependent variable. So our dependent variable is the continuous, that is the credit score after, and now we are looking at with the economic status. We are looking at with economic status as our factor variable. That is now the one-way ANOVA. So you can check if you have any additional, but that's not important. The post-Haki, but these are some of the assumptions. These are some of the assumptions actually that you also need to consider at times. But we'll talk more about this when we'll be doing ANOVA test. They are actually important. And what you can notice from this is that the post-hoc multiple comparison is that we have equal variance assumed and equal variance not assumed. So here you make a decision of which type of test to choose based on the fact that you would have done the test for equality of variance. Now using what we call the Levin test. Now if you have done the test for equality of variance, you come and the assumption holds, that is equal variance assumed. Now you select one here of this, and most of the cases we go with that. Now, if it does not hold, then you choose any. Then you choose, you choose one from here. And in most of the cases, we also use that. Or you can now do both. But of course, you need to do the Lavin test. And you can as well leave it as default. And click OK. And click OK. And it will give us our ANOVA table. It will give us our one-way ANOVA table. So it's just the same. The decision rule is still the same. You can use, okay, I'm not going to talk about the statistics here. What I'm interested is to make the conclusion and come up with a report. So there's some statistics behind this, between groups, within groups, and all that, and the mean squares. But the most important for the ANOVA test is the F statistics, the value of the F statistics, and its significance. Now, of course, in this case, you can use the F table, read the F table, and compare with the F that you are having here. And compare with the F that you are having. Now, okay, I'm not going to do that because we don't have the table. But we normally use the significance in most of the cases. So if the significant level is less than 5%, of course we reject. And if not, we fail to reject. We fail to reject. So you see, the decision rule is more or less the same. Now, from this, I can say the output of the ANOVA table shows that the significance of the F statistics is 0.00, which is less than 5%. So we therefore reject the null hypothesis and conclude that economic status has no impact. And conclude that economic status has impact on credit score of students. Remember, our null hypothesis is it has no impact, and we are rejecting that. So then we conclude it has an impact on credit score of students. On credit score of students. I think that is okay. Now you see, you can formulate as many claims as possible and try to determine the test statistics. Like from this data set, I can also see I have economic status and marital status. Do you think they could have a correlation or association? Maybe because you are married. Because here I see married, low, single, high, single, low, single. So maybe you can explore that. Again, you can do a chi-square test. There is another one that you can do. And also, lastly, you can also, you see, we have been focusing on the credit score. And at one point, we have been even coming up with some conclusion that this has an impact on credit score. This has an impact on credit score. So how about now determine the coefficients of those impacts? Like now getting the regression model, because still in threshold, that now will give us actually the magnitude of the impact. Maybe we look at credit score, maybe we regress it with economic status because there was a significant impact like we are seeing, and maybe with the there was wealth background as well, you see, and such, so that maybe we can get some more and more insights. So there are quite a number of claims that you can generate and make a conclusion, and test and make a conclusion about them. So I'll leave that with as an assignment. I'll leave that as an assignment. Go and do more claims. There are more tests that we have not covered. Try to come up with some conclusions, and then at the end of the day, you can even come up with a final conclusion. So like I was telling you at the beginning, actually this research study had two parts. We had the qualitative and the quantitative. So this is the qualitative, and we now had, this is the quantitative, and now we had the qualitative. So the report that maybe I'll share, because I'm not sure if I'll sit down write again, but I'll just try to source or rather fish from what I wrote last time. So expect maybe it will have some part of the qualitative. Never mind about that. So I think we have done enough with this data set. Maybe someone is having a question. Kindly feel free to ask. Now, anything about SPSS, data analytics and such, even if it's about Excel, the one we started with, just ask. Any point that is not clear, you can also ask.